So what have you learned so far? Attractive fields are always considered negative and repulsive fields are always considered positive. This should become a bit more obvious as we go through this session. A gravitational field is a part of space where a mass shall exert a force on another mass. They are created by all objects with mass, even you. We can show gravitational fields by using field lines. You should note that all the lines have arrows since fields are vector quantities and they all point towards the mass. Gravitational fields are always attractive. This is an example of a radial field because the field radiates from it in all directions. But we also need to know about uniform fields, i.e. the field that would be exerted by a flat mass. If we zoom in towards the Earth, we can get an idea about how a uniform gravitational field would look. It's actually easier to see electric fields and field lines. Let's start with a radial field. You can see that the grass seeds align themselves along certain paths, and these show the field lines from the electric field generated by a positive point charge. But field lines are vectors, so what way do the arrows point? Well, physicists have adopted a sign convention again. The field lines show the direction of a force on a positive charge. So the field lines always go from positive charge towards the negative charge. Let's look again at the uniform electric field. Again, you can see that the seeds align themselves along certain paths, along certain lines. These are the field lines in a uniform electric field. Again, the arrows point from the positive to the negative. The lines of equipotential in a uniform field are shown like so. You can see they follow a pattern and are always equally spaced between the plates. If there is a stronger field, and it will be shown like so. You will simply see there are more field lines in the field. To calculate the potential at points in the field, we use the two formulae we discussed earlier. So, give yourself a reminder of how to calculate the potential before you demonstrate your understanding in the next slide. Try both of the questions on the next slide to test your understanding.